So as I've mentioned, there's a connection between Pascal's triangle, Pascal's identity, and combinations. And one way of proving Pascal's identity is by expanding it out using the formula for combinations that we have been using thus far in the unit. So let's try to prove this thing here. We'll start with our left-hand side and our right-hand side. Okay? And on our left-hand side, the first term here is just n choose r. So let's just expand that using the formula for a combination here. N factorial over n minus r factorial times r factorial down on the bottom. Our second term is again going to be another combination. We're going to have n factorial up on the top. And because we've got r plus 1, we want n minus, and I'm going to put the r plus 1 in brackets, just to remind myself that that negative sign gets distributed to both the r and the plus and the 1. And then over here, I'm going to have just r plus 1 factorial. Now, my right-hand side, I haven't left myself a lot of room here, so I'm going to have to squeeze this in here, my right side. Let's just apply the combination formula. Again, we're going to have n plus 1 factorial divided by n plus 1 minus r plus 1. And again, I put the n plus 1 and the r plus 1 in brackets. And this whole thing, we're doing the factorial of. And then we're going to do r plus 1 factorial. Okay. So what would I do first? Well, first thing I'm going to do is I'm going to simplify these cases, these spots where I have n minus something in there. So on the left side, I'm going to have n factorial, n minus r factorial plus n factorial. N minus r plus 1 is going to be n minus r minus 1 factorial, and then r plus 1 factorial. On the right side, I'm going to have n plus 1 factorial. N plus 1 minus r plus 1 is going to simplify because those 1s are going to cancel out. I've got a plus 1. I'm subtracting a plus 1. So I'm just going to have n minus r factorial. R plus 1 factorial. Okay? And we're going to be done with the right-hand side now. We're not going to touch it after this. So what we're trying to do now is we're going to try to get the left-hand side to look like the right-hand side. I've got an n factorial and n factorial, and I've got two terms on the left-hand side. I would like to combine them together to get one term, because I have one term over here on the left-hand side. So if I'm going to combine these things together, I need to get a common denominator. So I want to turn this n minus r minus 1 factorial here into an n minus r factorial. Okay? Get this and this to match up, because I have an n minus r factorial on the right-hand side. I also want to turn this r factorial into an r plus 1 factorial, because then it would match up with this term over here as well. So how can I change those factorials into what I want? Well, what's the relationship between, let's do the r factorial and the r plus 1 factorial first. We know from our work in the previous unit that r plus 1 factorial is equal to r plus 1 times r factorial. So if I want to get this r factorial to be an r plus 1 factorial, I have to multiply it by r plus 1. So I'm going to multiply right in here. I'm going to multiply by r plus 1 in the denominator. I'm going to do the same thing up top. As long as I do the same thing to the numerator and the denominator, I don't change it. what about n minus r minus 1 factorial and n minus r factorial? Well, n minus r factorial is going to be equal to n minus r times n minus r minus 1 factorial. Okay? We're just sort of subtracting one down. Okay? So if I want to turn this n minus r minus 1 factorial into an n minus r factorial, I have to multiply it by n minus r. So I'm going to do that top and bottom. That looks kind of like an r. Let's make it look more like an n. Okay? And that is the trick, okay, to getting all these factorials to match up. Because now what I have is, if I come down a little bit here, I have n factorial times r plus 1 plus n factorial times n minus r in my numerator, all divided by, I've changed this r factorial times r plus 1 into n r plus 1 factorial. So let's make that r plus 1 factorial. And I've changed this n minus r minus 1 into n minus r factorial. Okay? So I've added those two together, having gotten my common denominator. How can I make this thing here, right here, look like this thing up here? Well, I've got the denominators matching up. N minus r factorial, r plus 1 factorial. What can I do in the numerator? I've got an n factorial and an n factorial in both terms. I can factor that out. So if I factor out n factorial, I'm left with an r plus 1 from this first term plus an n minus r from that second term, all over n minus r factorial, r plus 1 factorial. Well, what do I get here when I simplify this thing in the square brackets? R plus 1 plus n minus r. These r's are going to cancel here and here, and I'll just be left with n plus 1. So I'll have n factorial times n plus 1, all divided by n minus r factorial over r plus 1 factorial. What do we get when we multiply n factorial by n plus 1? We get n plus 1 factorial. So n plus 1 factorial over n minus r factorial all over r plus 1 factorial, which lo and behold is exactly what we had on our right-hand side. And that's our proof.